And here we go. We always start with this piece. We have the area beneath the curve, f of x equals 4 plus 2x minus 1 half x squared from 2 to 5. That means that the definite integral is from 2 to 5 of 4 plus 2x plus 1 half, minus, excuse me, dx. We'll talk about what the dx means in a second. But if we want to write that as the infinite limit of Riemann sums, we have to start with the width of n rectangles. 5 minus 2 over n is 3 over n. Very good. Close? Not quite. It's all shifted over 2 units. So the x values, or x of I, is going to be equal to 2 plus 3i over n. So remember, we start at 2, and then we add 1 width, 2 widths, 3 widths, 4 widths, so on and so forth. That's what we're doing. That's what I is. It's the number of widths. We start with widths equal to 1, and we go to infinity. That's equal to the limit as n goes to infinity, no big thing. Sum from I equals 1 to n. And it's f of x of I. What does that mean? Plug the x of I in. Wherever there's an x, I get 4 plus 2 times 2 plus 3i over n. And I take that quantity and multiply it by the width, 3 over n. Remember, this is delta x here, and this is f of x of I. So as you look at the definite integral, because tomorrow I'm going to teach you how to do the definite integral through the Fundamental Theorem of Calculus Part 2. And you're going to love it. If you look here, see the dx? Dx means delta x. That's your width. It becomes an infinitely small width. This is your function. Here's your function with the x of I plugged in, and then your integral and our sum with the limit. So they're kind of interchangeable. So, well, I got some work to do because that's really messy, isn't it? It's a good thing that you're so good at algebra. Okay, better multiply this out. I have 4 plus 4 plus 6i over n minus, oh boy, I got to square this out. 2 squared times 1 half, it's a minus 2. And then when I FOIL this out, I'll have to double it, right? So I'll get 6i over n, doubled will be 12i over n, times negative 1 half is negative 6i over n. 3i over n squared, 9i squared over n squared, and then times 1 half, so minus 9i squared over 2n squared. And that's all being multiplied by 3 over n. I've seen a number of people lately that they're forgetting their 3 over n, their width at the end. Don't forget that. It's delta x. Okay, sweet. Well, I can trim this down. Limit as n goes to infinity of the sum from I equals 1. And yes, you guys, you need to continue to write limit as n goes to infinity of the sum from I equals 1 to n. This is your mathematical language. Just like in English class, you're asked to use nouns and subjects and verbs and periods, capital letters. This is your mathematical language. Communicate it correctly. I will be picky on the test. Combine it together. What do I get? All right, so I got 6 there. Those go away. That was pretty nice, huh? Times 3 over n, which is the limit as n goes to infinity of the sum from I equals 1 to n of 18 over n minus 27I squared over n cubed. Right? We pared that down pretty well. Don't you agree? Notice that the n's are 1 degree larger than the i's in the numerators. That's a way to check to make sure you've counted for some appropriate pieces. A lot of people in their homework are forgetting to square stuff out so they don't FOIL it out. Oh, yes, thank you. 2 and a third. Yep. Yep. Yes. So, away we go. Find the limit. The limit as n goes to infinity of, I'm going to factor out the 1 over n, okay? So 1 over n times the sum from I equals 1 to n of 18. If you wanted to, you could have taken out the 18 as well. It doesn't matter. We'll show you how that works. Minus 27 over 2n cubed times the sum from I equals 1 to n of I squared. Okay? I got to substitute something in there. That's a constant, right? So I put the constant times n is what is substituted in. Yeah, so 18n. Now notice if you would have put the 18 here, then what would you put there? 1, so you'd have 1n. Either way, you just end up with 18, don't you? We have the limit as n goes to infinity of 1 over n times 18n. So whether the 18 is up there or out there, you're going to end up with 18. Minus 27 over 2n cubed. I got to substitute something in for that. We've used that before, haven't we? Some of the people during second hour got tired of always multiplying it out, so they just wrote it over on the side over there already multiplied out. So that's fine. Put them in. All right. Okay, so let's go to work here. We have the limit as n goes to infinity of 18 minus 54n cubed (81n squared). Kelsey's on fire today. All over 12n cubed. Limit as n goes to infinity of 18 minus, what do we take out of the top? N cubed. No, it would not. So it is important on the test that I see that the factoring is going to give you the 0. So that's what you're trying to communicate. We all know that this stuff all does go away. Nope, nope. Junk is not a term that we use in mathematics. So cross out the n cubes. The 81 over n and the 27 over n squared will go to 0 due to the infinity. And so anybody know the limit of a constant? It's a constant because the limit refers to the y value, and 18 is just simply a horizontal line, correct? So that always approaches a height of 18. It's always 18. So the limit of a constant is a constant minus 54 over 12. I can simplify that. 18 minus, let's see, 54 over 12 divided by 6. So I've got 9 over 2. So 36 over 2 minus 9 over 2 is 27 over 2, or 13.5. I'll accept either or. I am skeptical because that seems a little crazy. So I type in the function. I go second calculate. I grab number 7. I go from 2 to 5. I see the rectangles drawn. It never gets old to me. I've been doing this for years, folks. And the fact that we can find the exact area by adding up an infinite number of rectangles, it just blows my mind. It's unbelievable. It's beautiful. It's beautiful. Now, is there a shortcut to this? Yes, I'll show it to you tomorrow. But this is the calculus, the ability to calculate the infinite. Truly amazing. The rest of the hour is yours. Finish up your assignment. I have nothing new to you. So, if you missed yesterday, you might want to try to catch up on a little bit of your work.